In this video, we're going to talk about evaluating fractional exponent expressions, so actually getting a numerical answer at the end of these fractional exponent problems. All right, so make sure you're familiar with our exponent rules and what is a fractional exponent. All right, so just a quick reminder, a fractional exponent is just a shorthand for a root. So the 1/2, that 2 on the bottom means it's the square root. The 3 on the bottom means this is a cube root. So our first example, 16 to the 1/4 is the 4th root of 16. And learned about roots a while ago, but what does this mean? We're looking for some number that when I multiply it by itself 4 times, I get 16. Right? I'm trying to break down 16 into 4 equal parts. At the beginning, it might be a little guess and check. Always start off with 2. And it's 2, 4, 8, 16. So 2 is the one that works. So this is equal to 2. So 16 to the 1/4 equals 2. 27 to the negative 1/3. The first thing we always want to do is fix the negative exponent by moving it to the bottom of the fraction bar. Then I can make this a root. And now I'm trying to answer the question, what number do I multiply by itself 3 times to get 27? All right, 2 doesn't work. That's 2, 4, 8. But the next number 3 does work. It's 3, 9, 27. All right, so 1/3 is 27 to the negative 1/3. So here's one for you to try on your own. All right, 25 to the 1/2. All right, so pause the video, try that one. I'll show the answer in 3, 2, 1. And 1/2 means the square root, square root of 5. What times itself equals 25? The answer is 5. All right, so far, every fractional exponent we've had has just had a 1 in the numerator. All right, but what happens if we have more compact fractions, like 3/2 or something, instead of just 1/2? All right, so what we're going to do is kind of split it up into its 2 parts, right? If we have a over b, a is the same thing, or say a over b is the same as a times 1 over b. So we're going to separate the whole number part, the top part, from the fraction part. And then we can think about this in 2 different ways. We can either, right, we know if we combine these double exponents, it's multiplication, so we can combine them in either way. And actually this one will be more useful as we go. All right. In other words, x to the a over b is x to the a and then raised to the 1 over b, which is the fraction, or it's the bth root of x and then raised to the a. Again, this one will be more useful for most times when we're trying to evaluate an expression. So let's see what I mean. All right, 8 to the 2/3. The first thing I'm going to do is separate this out. There's not a 1 on the top, so I'm going to separate it out. It's 8 to the 1/3 squared. All right, so if I were to go backwards, I'd multiply these two. 2 times 1/3 is 2/3. So this is a fine thing to do to kind of break it up into the fraction part with a 1 on the top and the whole number part at the end. And 8 to the 1/3 is the cube root of 8. And that means I'm looking for the number that I multiply by itself 3 times to get 8. And that happens to be 2. That's the cube root of 8 is 2. 2 times 2 times 2 is 8. And now I can do 2 squared is 4. So my final answer, 8 to the 2/3 is 4. And here's why you could do it the other way. So I could do the same problem as 8 squared to the 1/3. And then I do 8 squared is 64. And I had to find the number I multiplied by itself 3 times to get 64. And that ends up being 4 as well. So either way gives me the same answer. But in this way, I make the number smaller first before I do the exponent. This way I make the number big and then try to do a root. And that tends to be a little bit harder just because the numbers are bigger. There's nothing really wrong or more difficult about this left-hand side. It's just that 64 is a bigger number than 8. So 81 to the negative 3/4. The first thing I'm going to do is fix that negative exponent by making it 1 over 81 to the 3/4. Now it's positive. I'm going to break it up into its 2 parts. Again, I typically do the fraction 1 over 4 part separate from the whole number part, 3. I remember that my fractional exponents is the same thing as a root. I remember what a root is. A root is trying to multiply a number by itself 4 times to get 81. 2 doesn't work, but 3 does. And then 3 cubed is 3 times 3 times 3 is 27. So 81 to the negative 3/4 is 1 over 27. All right, so here's one for you to try on your own. I figured out 32 to the 3/5. All right, so pause the video, try that one. I'll show you the answer in 3, 2, 1. Again, separate it out. 32 to the 1/5 is the 5th root. 5th root is 2. 2 cubed is 8. So hopefully you got 8 as your final answer. All right, so remember that fraction in an exponent is just a root. And combining fractions with whole numbers, I always like separate out and do the root part first, so the 1 over the bottom first. And then whatever that top value was, that's your like whole number exponent. All right, so just real quick, if I had like this, I'd always do the root part first, just change this to a 1, and then do the whole number